Dear students, welcome to this course of engineering mechanics. And first, we will discuss statics. So let us have an introduction to statics. So these are the contents of the introduction. First, we will see what is mechanics. Then we will study different fundamental concepts and then the different fundamental principles. Then we will see about different type of system of units that you will see in your mechanical engineering problems. Then we will see how to solve the different problems, and then about the accuracy, numerical accuracy of the solution. So let us start. First, let us see what is mechanics. So as you can see, mechanics is the science which describes and predicts the conditions of rest or motion of bodies under the action of forces. So if you are having some bodies that are under the application of different forces, then by using mechanics you can predict the conditions of rest or motion of the bodies by applying the laws of mechanics. Now you can classify the mechanics or different type of bodies as rigid bodies mechanics. So in rigid bodies we can have statics and dynamics. So whenever you are studying the bodies which are rigid, then you have to study statics. When your bodies are in rest, then you have to study statics. And if your bodies are moving under the action of forces, then you can call it dynamics. Then you can have deformable bodies. So some bodies deform under the action of forces. So then you have to use different laws. Our syllabus is limited to only this part, statics and dynamics. And there are then you have the fluids. So for studying fluid, you will have different subjects like fluid mechanics, fluid dynamics. So in mechanics, we are studying rigid bodies only, and rigid bodies can have two types of mechanics: statics when your bodies are in rest, and dynamics when your bodies are moving under the action of forces. Now mechanics is an applied science. It is not an abstract or pure science, but does not have the empiricism found in other engineering sciences. So mechanics is the applied science, means it is based on certain laws of physics, laws of motion. Okay. And mechanics is the foundation of most engineering sciences, especially in designing of machines, designing of equipments, designing of structures. Mechanics is used. So mechanics is the foundation of most engineering sciences and is an indispensable prerequisite to their study. So if you want to study different type of engineering courses, and then you have to study mechanics, because you will be applying the principles of mechanics everywhere. Whenever you are designing certain machines, certain structure, certain equipments, for that you need the principles of mechanics. You need to calculate the forces. You need to predict the conditions of rest, conditions of motion. Now we will see about different fundamental concepts that you will encounter in your mechanics course. So one such concept is the space. So what is the space? Associated with the notion of the position of a point P, given in terms of three coordinates measured from a reference point or origin. So whenever you are solving some mechanics problems, then all the bodies, they must be present somewhere, and that somewhere is the space. And you can represent the bodies by the coordinates. So there is some reference system. Suppose you may have your x, y, z, and the reference system has origin, and your bodies, they may be represented by a position coordinate P, and this is the space. Okay, then another very important fundamental concept is time. So from the time, definition of an event requires specification of the time and position at which it is occurred. So if you are studying a rigid body that is moving, then you need to know that at a particular time, whether it is moving, whether it is fixed, whether it is in the state of rest or in the state of motion, and after the period of certain time, what is the position of the body. So you need to specify those things. Okay, suppose initially your body is at rest, it is having velocity v is equals to 0 at time t is equals to t1, and after a certain time, say t is equals to t2, it is possible that your rigid body or the system of a rigid body, it is moving with a certain velocity, say 2 meters per second. Then you also need to specify some direction also. Then another important fundamental concept is the mass. So mass is used to characterize and compare bodies. So certain bodies are lighter in weight, they are having less mass, and because of less mass, the Earth's gravitational attraction force is also less, and also if you are sliding your body, then it is having a less frictional force. If the mass of the body is higher, then it is attracted by a larger force towards the earth, and also the resistance force will also be higher. And another important fundamental concept is the force. So force represents the action of one body on another. So how one body is having action on another body, and a force is characterized by point of application, magnitude, and direction. So whenever you are talking about a force, you need to specify these three things. At which point your force is applied, what is the magnitude of that force, and what is the direction of that force. Only then you can know the effect of that force. So if there is some body, suppose this is your body, and suppose you are applying a force, then you are having a point of application, then you have the magnitude. So sometime magnitude is represented by the length of the arrow, and by this you can represent the direction of the force. So in Newtonian mechanics, space, time, and mass are absolute concepts independent of each other. So the space, time, and mass, they do not depend on each other, they are independent to each other. While force is not independent of other three. So force depends on space as well as time as well as on mass. So the force acting on a body is related to the mass of the body and the variation of its velocity with time. Now there are certain fundamental principles which you might have studied in your physics course. So one such fundamental principle is the parallelogram law. So if there are two vectors P and Q and they are represented by two arrows, so this is the direction and the length of the arrow will represent the magnitude. So suppose if you represent the two vectors by the arms, two sides of the parallelogram, and you complete the parallelogram, then this diagonal of the parallelogram will represent the resultant of these two vectors. So if P and Q are the forces, then this R is the resultant of P and Q. So if you are representing P and Q separately, or if you want to represent them in a combined form, then you can represent by them by R. Then another principle is the principle of transmissibility. So suppose, as you can see, this is your rigid body and you are applying a force at this point. Suppose you are pulling this body in this direction, and if you draw a line passing through this force, this is the line. What principle of transmissibility says? It says that along this line, the line of application of the force, if you change the point of application, so here the point of application is this. Now suppose you have changed the application to this point, but all other things, means the magnitude of the force, direction of the force, it is same, then this will have the same effect on the body. So the effect produced by this force F and this force F dash will be the same. So this is called as the principle of transmissibility. Then other fundamental principles are the Newton's laws of motion. So these laws you also studied in your physics course. So Newton's first law, what it says? It says that if the resultant force on a particle is zero, the particle will remain at rest or continue to move in a straight line. Okay. So suppose this is the body. Okay. Suppose one force is applied here, one force is applied here, and one force. So we are having three forces on this body. This is your body. Now if the resultant of these three forces is 0, and suppose initially the body is at rest, and if you apply three forces and the resultant of all these three forces are 0, then according to first law, this body will remain in rest because no net force is applied. We applied three forces, but the resultant of the three forces is 0. And similarly, if the body is moving with a constant velocity and then we have applied all these three forces, and it will continue to move with the same velocity. So this is the first law. And then next, Newton's second law. A particle will have an acceleration proportional to a non-zero resultant applied force. So now if the resultant force, they are not 0 but they are having certain magnitude f, okay, then the acceleration of the particle because of this unbalanced force will be directly proportional to the acceleration. And if you write in the form of equality, then you can write as F is equals to m into a. So a particle will have an acceleration proportional to a non-zero resultant applied force. So F is directly proportional to the acceleration. And third is the Newton's third law. So it says that the forces of action and reaction between the two particles have the same magnitude and line of action with opposite sense. So suppose if you are having, say, a wall and you have applied some force F. So this force you have applied on the wall. Suppose you are punching the wall, okay? Then you also feel some pressure on your hand. So what is this? That force is applied by the wall on your hand, and it will have the same magnitude, but the direction of that force will be opposite. Magnitude will be the same and line of action will be the same. So this is the Newton's third law. So these are the fundamental principles. Then another one is the Newton's law of gravitation. I just forgot. So what it says, two particles are attracted with equal and opposite forces. So because of the gravitational force, two particles, suppose one particle is having a mass capital M, another particle is having a mass small m, and they are attracted towards each other by this force F, which is equals to Fg mm upon r square, where r is the distance between the particles and g is the gravitational constant. Now we will see the different system of units that you will be using in your mechanics course. So you will be having units for length, time, mass, and force. Okay. Three of the kinetic units referred to basic units may be defined arbitrarily. That is, you can define the unit of length, then you can define the unit for time. So for, say, length for meter, for time you can define second, for mass you can have kg. Okay. The fourth unit, which is also called as a derived unit, must have a definition compatible with the Newton's second law. So the unit for force you will find by using second law. Okay. So According to the SI units or International System of Units, the unit of length is meter, the unit of time is second, the unit of mass is kilogram. Then force, which is the derived quantity, the unit of force will be this kg meter per second square, and 1 kg meter per second square is also defined as the Newton. So 1 Newton will be 1 kg meter per second square. Then you can have some other units also. So in different countries, sometimes different units are used. For example, in the US, sometimes they use feet for this length. For time, they use second, and for force, they use pound. So in the US, they are treating this force as the basic quantity. Then mass is the derived unit in that case, and the unit of mass is slug, which is equals to 1 pound divided by 1 foot per second. Now we will see the method of problem solution, how you are going to solve your problems. So first thing is the problem statement, means you should know about your problem clearly. Okay, what is the dimensions, direction of forces, if the forces are applied, figure showing all the quantities. Okay, then specification of what is to be determined. So all these things should be known clearly. Every data, even if a single data is missing, then it might create problems and you will not be able to solve your problem correctly. So first thing is the problem statement. Then second most important thing in mechanics is to make the free body diagrams. So generally, whenever you are solving the problem in mechanics, it involves different bodies. So in free body diagram, what you have to do, you have to create separate diagrams for each of the bodies involved. So if you are having two bodies, then you have to make two free body diagrams. If you are having three bodies, then you have to make three free body diagrams with a clear indication of all forces acting on each body. Okay, so you have to make the free body diagram for every body, and you have to indicate all the forces. That also includes the interaction forces between two bodies. Okay, and after you make the free body diagrams, next step is to apply the fundamental principles which we have just discussed in the previous slides. So these 6 fundamental principles are applied to express the conditions of rest or motion of each body. Then you will apply the rules of algebra to solve the equations for the unknown quantities. So some quantities are known to you, while some quantities are unknown. So by applying the fundamental principles and rules of algebra, you will be obtaining unknown quantities. And the last step is to check your solution. So in this, what you can do, you can test for the errors in reasoning by verifying the units of the computed results. Then you can test for errors in computation by substituting given data and computed results into previously unused equations. And then the last step is you can always apply your experience and physical intuition to access whether result seems reasonable. Okay, suppose you are having three bodies and one body you are having say 4 Newton force, another body you are having say 5 Newton force, and for third body you are obtaining say 100 Newton force. So that may looks unreasonable. Okay, so you can use your physical intuition and experience that whether the result seems correct or not. Now next is the numerical accuracy. The accuracy of a solution depends on 2 points. First one is the accuracy of the given data. Okay, so if the data which is given to you, that data is not accurate, that's all, your solution will also be not that much accurate. Okay, so you need to make sure that the whatever data you are having, that data should be accurate. And second is the accuracy of the computations performed. So whatever computations you are doing, you are using some calculators or some software, so you should make sure that computations are performed with accuracy. The solution cannot be more accurate than the less accurate of these two. Okay, so suppose you are having this data up to say 1 decimal place, but the accuracy of your computation is up to 2 decimal place, then your solution should be accurate to up to 1 decimal place only, because your first data is only up to first decimal place accurate. Okay, so the use of hand calculators and computers generally make accuracy of the computations much greater than the accuracy of the data, and the solution accuracy is usually limited by the data accuracy. So this, for the second part, you are using calculators, computers, Excel sheets, so on. So this is generally very accurate. So generally the accuracy of your solution is limited by the given data. So as a general rule for engineering problems, the data are seldom known with an accuracy greater than 0.2%. So generally up to this 0.2% you know the data accurately. Therefore, it is usually appropriate to record parameters beginning with 1 with 4 digits and with 3 digits in all other cases. So suppose if it is not beginning with 1, so it is beginning with 4, then you should record in 3 digits. Okay, and if beginning with 1, then you should record 4 digits. Okay, so these are the contents of this lecture. First, we will have a look to applications. What are the applications of statics of particles? Then we will have the introduction. Then we will discuss the resultant of multiple forces acting on a particle. So we will discuss the resultant of two forces. Then we will study something about vectors, like addition of vectors and resultant of several concurrent forces. And then we will solve sample problems. So these are some of the applications. I am showing you only one application. So as you can see in the figure, Suppose this crane is hanging by these ropes. So in this slide, you can see the applications. So suppose this crane is hanging by these ropes. These 4 ropes are there. So by the principles which you will study in this, now we will see the introduction. So the objective for the current chapter is to investigate the effects of forces on particles. So suppose if you are having some particles, single particle or a group of particles, then you can investigate the effects of different forces that will be acting on the particles. So first thing you will understood in this chapter will be the effect of forces on particles. The next thing which you will learn in this lecture is the replacing multiple forces acting on a particle with a single equivalent or resultant force. So sometimes, suppose this is the particle and some multiple forces are acting on the particle. Suppose these 3 forces are acting, then you can replace all these 3 forces by a single resultant force, which is having the same effect as the effect of all these 3 forces. Okay, so this you will learn. The next thing you will learn relations between forces acting on a particle that is in a state of equilibrium. So suppose this particle is in the state of equilibrium, that is either it is in the state of rest, or this particle is say moving with some constant velocity. Okay, so what is the relation between the forces? Suppose these 3 forces are applied, and these 1, 2, and 3, and this particle is in equilibrium, then we can learn the relation between the forces. What is the relation between 1, 2, and 3? That you will learn. Okay. Now let us see the resultant of 2 forces. So suppose this is the force. So force action of one body on another. So this we have already studied in previous chapter, that if there are more than one bodies, then action of one body on another is called as force. Okay, and a force is characterized by its point of application, magnitude, line of action, and its direction. So this we have learned in the previous lecture also. So whenever some force is applied to a body, then you have to see where this force is applied, the point of application of the force, magnitude of the force, line of action of the force, and direction of the force. Now suppose we are having 2 forces, P and Q. So this is the force P, this is the force Q. So experimental evidence shows that combined effect of 2 forces may be represented by a single resultant force. So from experiments also you can verify this thing, that if there is a body and some multiple forces are acting on the body, And if you apply a resultant force which is equivalent to the resultant of all the forces, then the effect will remain same. Okay, means the effect which is produced by P and Q is the same as the effect which is produced by R. Okay, and the resultant is equivalent to the diagonal of a parallelogram which contains the two forces in adjacent legs. So this we have already also discussed in the previous class, that suppose these are the two forces P and Q. So if you draw these forces as the two legs or two sides of this parallelogram, then the resultant will be represented by the diagonal of this parallelogram. This is also called as parallelogram law of vector addition. And force is a vector quantity. So this thing all of you knows, force is a vector quantity. That is, now vectors. So this you might have studied in your physics class also. What is a vector? So any quantity which possesses magnitude. So let us now understand about vectors. Any quantity which possesses magnitude and direction. So any physical quantity which is having both the things, that is magnitude and direction, and which we can add according to the parallelogram law. So that is called as vector. So the examples of vector are displacement, velocities, and acceleration, and force, and so on. There are different vector quantities. Then there are some physical quantities which do not need any direction. So they are called as scalar. So they possess only magnitude and no direction. Direction is not important for them. For example, mass. So we do not need any direction to specify the mass. Similarly, volume, temperature, etc. So now how you can classify vectors? So there are fixed or bound vectors. So they have well-defined points of application that cannot be changed without affecting an analysis. So some vectors, they have fixed and bound, means they have definite point of application, and you cannot change the point of application. If you change the point of application, then the results will also change. So that is called as fixed vectors. So fixed vectors are those which we cannot change, means they have to remain at a specific point. Then there are free vectors that can be freely moved in space without changing their effect on an analysis. So free vectors are those vectors that you can move along the line of action, or in a space. You can also move in a space, and there will be no effect of those vectors in the analysis. Means if you move the free vector, then the analysis will remain same because they are free vectors. So they do not have any effect on analysis. Means you can change their position and the analysis will not change. Then third is the sliding vector. So it may be applied anywhere along their line of action. In the previous video, we have discussed about so now we will see addition of vectors. So first one is the trapezoid rule. So that is same as the parallelogram law. So if you draw the trapezium, if you have two vectors on the two sides of this parallelogram, then the resultant will be the diagonal of the parallelogram. So this is also called as trapezoid rule. Then another rule is the triangle rule for vector addition. So in the triangle rule, what you will do, suppose this is the first vector P, then what you will do, you will put the this bottom of the other vector at the tip of this. So you will start. I will suppose I will draw here. So suppose this is the first vector P. Then you will start from the tip of this. The next vector you will draw from the tip of this. And suppose the vector is starting here and it is having this direction. So this is Q. Now the resultant will be this when you close this triangle, when you complete this triangle. So resultant will be this. Okay. And the direction will be opposite. Suppose you are moving this, and the direction of resultant will be from here. So the same thing is explained in this figure. So here we have taken Q first. So you can take any vector first. So here they have taken P first, and this is at the second number. In this B figure, Q is taken as the first, then P is drawn, and then this P plus Q. So it will remain same. You can also say that vector addition is commutative, and you can calculate the also by the law of cosines. So if this is the P and Q, then you can calculate R by this. Means magnitude you can calculate by this. P square plus Q square minus 2PQ cos B, where this B is the angle between the vectors. Okay. And the relation between the angles is by the law of sines. That is sine A by Q will be equals to sine B by R will be equals to sine C by A. Okay. So suppose Q is this. So then sine A by Q, sine B by R, and sine C by A. And this thing we already know, vector addition is commutative. That means either you are adding P plus Q or Q plus P, you will obtain the same answer. Means the resultant vector will be same as shown in these two figures A and B. So either we are adding P plus Q or Q plus P, we are getting the same vector. Means its direction is also same and its magnitude is also same. And then vector subtraction. So vector subtraction is the basically the addition of vector with a negative vector. Okay. So suppose if you want to subtract P minus Q, then what you will do? You will take P and you will take the negative of Q, means you will reverse the direction of Q vector, and the resultant will be P minus Q. Now let us see the resultant of several concurrent forces. So suppose we are having a point A. So first we should know what are the concurrent forces. So if all the forces they are passing through the same point, then those forces they are called as concurrent forces. So because these forces P, Q and S, they are passing through the same point A, so all these forces they are concurrent forces. And we can replace all these forces by a single resultant force, which is the sum of the applied forces, vector sum of the applied forces. So you can replace these forces P, Q and S by a single force R, and this R is the sum of these forces, and it will have the same effect as all these forces will together have. So how you can calculate the resultant? You simply draw one vector, then you draw second vector from the tip of first vector, then you draw third vector from the tip of the second vector, and then you simply close the polygon. Okay, so this is also called as polygon law of vector addition. Now another very important thing is the vector force components. So because sometimes when you are solving the problems, so you have to divide the force into two components. So suppose your force is acting in any arbitrary direction and you want to resolve the force into two directions, say x, y and z. So sometimes it's two direction when you are solving the problem in 2D, and sometimes you are solving the problem in 3D, then you will resolve the force in x, y and z direction, all the three. So suppose this is your initial force F. So you can resolve in direction P. So this direction and denoted by as P, and in this direction and denoted by as Q. So these two components P and Q, they will have the same effect as P. So this is just the reverse of addition, you can say. So when you add P and Q, then the F will have the same effect. Now you are dividing F into P and Q. So this is just reverse of the. Now we will solve a sample problem. So this problem contains a bolt and two forces P of 40 Newton and Q of 60 Newton are acting on this bolt, and the inclination of force P is 20 degree from horizontal, while inclination of force Q is 25 degree from P. So we have to find the resultant of these two forces. Now what strategy you can adopt for the solution? So you can adopt graphical solution strategy, as well as you can solve by using the equations. So in graphical strategy, graphical solution, you can solve by drawing the parallelogram law. In parallelogram law of vector addition, you have to make the parallelogram by considering P and Q as two sides, and then you can make the diagonal which will represent the resultant of two forces P and Q. So this you can do in graphical technique. Another one method of graphical solution is the triangle rule. So you can make the triangle, and you can also use the law of sines and law of cosines. So you can use any one of the method, whichever you feel comfortable. So this is the graphical solution of the problem. So what we have done, so suppose this is the horizontal. So we have drawn P, and this angle will be 20 degree. Okay. Then you can take 25 degree and draw Q. And this length is suppose say 4 centimeter. And this length is 6. So now you have drawn the two sides of the parallelogram. Now next step you can do, draw a line parallel to this. So this line, this line is parallel to this line, AP, and another line you will draw parallel to this. So this is the this line is parallel to this. So in this way now your parallelogram is complete. So now you can draw the diagonal. This is the diagonal, and you can measure this angle alpha, and you can measure this length, this length. So when you measure this length, you will find the length will be 9.8 if you have drawn in the centimeter scale. So then the answer will be 98 Newton, and this angle will be 35 degree. Yes. No, this is the graphical method. We will discuss the theoretical method also. Okay. Similarly, when you draw the triangle law. So this is the triangle law solution. So first you draw P. So this angle is 20 degree. Then what you will do, from the tip of this, you will draw the second vector, and this inclination should be 45 degree. Okay, because this 20 and 25. And next what you will do, you will complete this triangle. So again you will measure this length and this angle. Then you will find there this will is the length will be 9.8, so 98 Newton, and angle will be. So this is this method. Okay. So law of cosine says that the resultant of two vectors will be p square plus q square and minus of 2 pq cos b, where b is the angle between the two vectors. Okay. So p is 40 Newton, q is 60 Newton, and this angle between both the forces will be this one. So it is 55 degree, 155 degree. So if you solve this equation, then you will find the answer as 97.73. Okay, so it is very near to 98. And you also have to find this angle alpha. So because this is only the magnitude, you also need to find the direction, so that you know the complete information regarding the solution. So for that you can use law of sines. So law of sines is this. So sine A by Q is equal to sine B by R. Okay. So sine B is this. You have just calculated 155 degree. Okay. Then Q is 60 Newton. We already know this. And R, this we have just calculated 97.3. So from this equation, okay, you can calculate sine A. Sine A will be equals to sine B. We have taken this Q here. Okay. So Q by R into sine B. So sine B you can calculate, Q you know, R you have calculated. So simply solve this equation and you will get A is equal to 15.04 degree, means this angle. This angle is A, 15.04. And with horizontal you will simply add 20 degree. So alpha will be, because alpha we will take from this horizontal direction. So we simply add this 20 plus A, means alpha by, so alpha will be 20 plus A, means 35.04 degree. So we are getting almost the same solution by using this law of sines and law of cosines. It is possible to resolve a force vector into perpendicular components. So suppose this is the force vector F. So we can resolve this vector into the components Fx and Fy in 2D. And if you want to resolve in 3D, then you can have Fx, Fy and Fz. So you can write F as Fx plus Fy. Now to do this, what we do, we define unit vectors. So we have defined two unit vectors, I and j. I is the unit vector in x direction and j is the unit vector in y direction. So I is parallel to x, j is parallel to y. Similarly, in 3D, z, we define z as parallel to z axis. So now if you want to resolve the force, you can do so by this method. F will be equals to Fxi plus Fyj, where Fx is the magnitude in the x direction. So this component is showing the magnitude Fx and I will show the direction. So Fxi means Fx in the x direction. Similarly, in the y direction we have Fyj. And these Fx and Fy are the scalar components of F. So they are the magnitudes and this will show the direction. So in this way you can break any force or any vector, whether it is displacement vector, force vector or any other vector, into the components. Now if you want to add forces by summing x and y components, then this method is very simple. So suppose you are having three concurrent forces. What is concurrent force? When your all the forces, they are passing through the same point. So here P, Q and S, they are passing through same point A. So that is why they are called as concurrent forces. So for the addition of concurrent forces, you simply need to add the three. R is equal to P plus Q plus S, and it is very easy. So suppose R is the resultant force. So for adding these three forces, what you have to do, you need to break the forces into the components and add the components in the same direction. So resultant will be Rxi plus Ryj, while on the RHS you can have, say, this is the force P. So you need to break this into Px and Py. So Pxi plus Pyj. Then similarly Q, you will break Q into Qxi and Qyj, then S. And what you will do, you will combine the forces in the same direction, that is in the x direction. We will combine Px plus Qx plus Sx, and we will write them into the bracket, then I. Now similarly Py plus Qy plus Sy into J. So this is how you can add the forces. And the resultant force you can represent like this, Rx and Ry. So Rx will be equals to Px plus Qx plus Sx, and Ry will be equals to Py plus Qy plus Sy. And the resultant magnitude R you can find like this. So this is the components Rx and Ry in the x and y direction, while R is the resultant. So to find the resultant, you simply square the components Rx square plus Ry square and take the square root of that. That will give you the magnitude of the resultant force. And simply take tan inverse of Ry and Rx, then you will get the direction of the resultant force with respect to horizontal direction. So this is how you can add the forces for any vectors that are passing through a concurrent point. So you simply break all the forces into the x and y components, add the x components together, add the y components together, then you will get the components of the resultant force. And by doing this, you can simply take the square the components and take the square root. You will find the resultant. And similarly, by taking the tan inverse of Ry and Rx, you can get the magnitude of the force. So when the resultant of all forces that are acting on a particle is zero, the particle is said to be in equilibrium. So when a particle is in equilibrium, that is, if the resultant force on a particle is zero, then according to Newton's first law, the particle will remain at rest or will continue at constant speed in a straight line. So suppose if this is the particle and two forces are applied on this particle. So one force is of 100 pound in this direction, while another force is having the same magnitude, that is 100 pound, but it is in the opposite direction. So these forces are equal in magnitude and they have same line of action, but opposite in sense, means their direction is opposite. So when you calculate the resultant of this, then obviously it will be zero. So we can say that this particle is in equilibrium because the resultant of the forces acting on this particle is zero. Now suppose if more than one forces are acting on the body. So this is the body or particle A, and there are two forces. Sorry, four forces are acting: F1, F2, F3, and F4. So now when you calculate the resultant of these four forces, and if the resultant is zero, then this particle will be in equilibrium. Now the resultant can be calculated by using the graphical solution. So when you will be using a graphical solution, then suppose this is the F1. So suppose I have drawn the F1 like this, and from tip of the F1 I have drawn F2, and from tip of the F2 I have drawn F3 like this, and F4 like this. So in case of the particle in equilibrium, the resultant should be zero. That means all the forces that are acting on this particle should form a closed polygon. Only then the resultant will be zero. So if you use graphical method, then if you start from one force and keep on making the other forces, and then you will end up at the starting point. Okay, another method which you can use is the algebraic solution. That is, summation of all the forces will be zero, and in that case the summation of the forces in the x direction should be zero, as well as the summation of forces in the y direction should be zero. And if you are applying the equilibrium in 3D, then summation of fz should also be zero. That is, in case of 3D, summation of fz should also be zero. So this is all about equilibrium. Equilibrium is very important, because whenever you are solving the problems, statics. So in statics, the particles do not move and they remain stationary at a particular point. So the particle or body is not moving. That means that it is in equilibrium. So whenever you are studying statics, your body is in equilibrium. That means all the resultant forces should be zero. So some forces are known to you, some forces are unknown to you. So what you will do, you will make different equations, like summation of x equal to 0 will give you one equation, summation of fy equals to 0 will give you another equation, and in case of 3D this will give you another equation. So in these equations you have some known quantities, you have some unknown quantities, and you can solve for the unknown ones. So this is how you are doing in your mechanics course. New mobility is electrical vehicle. So one thing is a space diagram. A space diagram is the actual sketch showing the physical conditions of the problem, usually provided with the problem statement or represented by the actual physical situation. So you can see in this figure. So everything is shown actually, as this is a truck, and they are loading some weight on this truck with the help of these strings, and everything is shown. So this type of diagram is the space diagram, while the free body diagram is the sketch that only shows the forces on the selected particle or body, and this diagram must be created by you. Whenever you are solving the problems, then you will create this type of diagrams. For example, for this figure, there are three forces which are acting on the particle. One force is the downward force, and this force is the force of weight because of the acceleration due to gravity. And there are two forces which are acting along the strings, and these are the tension forces as shown in the figure, TAC and TAB. And these forces are inclined with the horizontal with 50 degree and 30 degree. So this is the space diagram, and this is the free body diagram. This is one more problem. So this is the space diagram of the problem. So this boat is moving in the flow, and flow is in the opposite direction, and at a particular instant it is tied by three ropes, so that it will remain in equilibrium. And this is the free body diagram. So the one tension force will act in this direction. So we have drawn like this. Then another tension force will act along the AB. So this is drawn like this. Another tension force will be acting along the AC. So this is drawn like this. And one force, because of the flow, will act in this direction. And it is shown like this. Okay. And these are the angles alpha and beta, which you can calculate by using these dimensions. So this is how we can prepare the free body diagram. This figure shows another free body diagram. So as you can see, this weight is hanging by the crane through this rope, and this person is pulling this towards him. So in this, one force is the force of weight, which is in the downward direction. And then another force is the tension force along AC. So this is shown here. And another force is the tension force along BC. So this is shown here. And these are the angles. This angle is 5 degree and this angle is 20 degree. So this is how we can draw free body diagrams. And once free body diagram is drawn, then we can use the equilibrium conditions, that is summation of the forces should be 0, and by apply equilibrium condition it will result into the equations, and from the equations, by putting known values, we can solve for unknown forces and tensions. Welcome dear students. In this video I will discuss vector in 3D space, because in solving engineering mechanics problems you will encounter problems in which you have to deal with the three-dimensional objects or bodies. So you should be well aware about how to express force vector, displacement vectors in 3D space. Now let us see how we can express the vectors in 3D space. Suppose this is your vector f, and these are the axes x, y and z, and suppose this vector has its origin at, means this vector is starting from the origin O, and you know these angles, so it is inclined with angle theta y to y axis, and this plane in which we are having a vector OBAC, so this plane is inclined with the x-axis by an angle phi. Now first thing we can do is to resolve the components of this vector in this y direction and this horizontal direction. So for resolving in the y direction, it is very simple, because you know this angle. Then this Fy will be simply F cos theta y. Okay. And in horizontal direction, we can resolve similarly. Fh is equal to F sin theta y. This is the same as we are doing in 2D. So we are resolving the vector in this plane OBAC. So Fy will be F cos theta y and Fh will be F sin theta y. Now the next step is to resolve this Fh into x and z components, because in y we have already resolved. Now this angle we know phi from here. So this Fx will be Fh cos phi. So Fx is equal to Fh cos phi, and Fh you can replace from here, that is F sin theta y. So then your fx will be f sine theta y cos phi. Similarly, you can resolve this fh into z direction, that is fh sine phi. So fz will be fh sine phi, and once again we can replace fh as f sine theta. So f sine theta pi sine phi. So now all the three components are resolved. Fy is f cos theta phi, fx is f sine theta phi cos phi, and fz is f sine theta y sine phi. So if you know the angles and the vector, then you can resolve the vector in 3D in xyz direction. Okay, now let us move further. Now suppose you know the direction cosines. So this vector f, so it is inclined with the angle theta x from x-axis, then angle theta y from y-axis, and angle theta z with z-axis. So we know all the three angles of this vector. Okay, so now we can easily resolve into the component. Fx will be f cos theta x, fy will be f cos theta y, and fz will be f cos theta z. And also we can write like this: f is equal to fxi plus fyj plus fzk in the form of unit vectors, which we have learned in the previous video. So where I is the unit vector in x direction, and j is the unit vector in y direction, and k is the unit vector in z direction. Now we can replace fx, fy, and fz by these three expressions, and you can take f common. Then your f will be equals to, vector f will be equal to f cos theta xi plus cos theta y j plus cos theta z k. So this is also written like this: lambda. You can also write this term which is in this bracket as lambda, where lambda is cos theta xi plus cos theta yj plus cos theta zk. So if you know the angles from all the three axes, then what you can do? You can simply calculate delta, and you can write f as f into lambda. Okay, so this is how you can express if we know direction cosines. And this lambda, it is a unit vector along the line of action of f. Okay, so lambda is also a unit vector like this I, j, and k, because this I is having the unit magnitude, j is having the unit magnitude, k is having the unit magnitude. So in the same way, this lambda is also a unit vector, but its direction is the line of action of f. Okay, and these cos theta x, cos theta y, and cos theta z, they are the direction cosines for f. So you will understand it more clearly when we will be solving some problems. Okay, let us move. Now sometimes it is possible that the vector is not given from the origin. Okay, so your origin is here and your vector is here, and you know the coordinate of your vector. So its initial point is known to you, which is m, x1, y1, z1 are the coordinates of this initial point, and you know the final point, this. So the coordinates of this final points is x2, y2, z2. So this is the line of action mn, and in this line this force F is applied. So now what you can do, you can calculate the distance, sorry, displacement in x direction. So simply subtract x2 by x1. Then similarly in y direction and z direction. Then this vector joining mn, this vector will be equals to dx I, dyj and dzk. Okay, and we can also express in the form of lambda. So f of will be equals to f into lambda in the same way as we have seen in the previous slide. That is, you can express any vector f is equal to by its magnitude into the by multiplication of by a unit vector in the same direction. So we have done the same thing here. Now you can calculate lambda by this equation. So lambda will be equal to dxi plus dyj plus dzk by d. And these components fx will be f dx by d, f dy by d, and fz will be f dz by z. So this is how you can express when your vector is not originating from the origin. So whenever you are solving the problems, not always your vector originates from origin. Sometimes it is originating from origin and sometimes it has some coordinates. So whenever you are solving the 3D problems, you can use these equations to represent your vector. So this is all for today's video. Thank you very much. Thanks for watching. Have a nice day.